Hi guys, welcome back. So we are still busy with some finance and growth. In particular, we're looking at some simple growth, and under simple growth, we are looking at patterns. So let's just jump right into it. So remember that we said our big idea is growth, and we're looking at patterns under growth, and then we are specifically looking at a simple pattern or a simple growth, if you would like. Now, I want us to just explore some data. Now, with this data that you're going to talk about, let's say you go to the doctor, and then the doctor says to you, for your health purposes, you need to get to a certain number of steps in a day that you need to walk, because you know exercising at times is a bit of a problem because maybe some people don't have time or it's just too much for them. So they then say to you, no, just walk, right? But in your walking, you must get to 10,000 steps. So your goal is to get to 10,000 steps. We're going to look at the first days, because remember, with the first days of you walking or doing any exercise, you're going to start by just doing gradually the very same thing, kind of, just so that you can get the oomph of what you are trying to do, and you can get used to what you are doing in terms of walking or exercising. And then later we'll then look at what happens when you then change things around. So the very first week, the person then decides to say, day one, I'm going to walk 5,000 steps, right? Then day two, there is 5,000 steps. So the questions to you would be, was there any change between these 2 days in terms of the number of steps that the person walked? Day three, you look at, they walk 5,000 steps as well. Day four, they walk 5,000 steps as well. Day five, they walk 5,000 steps. So you can see that with the days, as the days progresses for the first week, the person is walking the very same number of steps. So we will then be looking at whether there is change, if our change is constant, if there is change. If there is no change, then what concept are we trying to talk about here? So clearly you can see that with this first example, there is no change. Why? The reason might be the person is still getting used to walking, because they were not used to walking, because I know some of us maybe we are not really big on exercising, but this might be very good for our health. So they decide to say, no, let me keep on walking 5,000 steps each day for the first week. And then gradually, I will then start increasing maybe my number of steps per day or something like that. So if I then put this on a graph, right? So initially, the person walked 5,000 steps, right? So this would be our day one. And day two, you know that they also walked 5,000 steps. Our day three, they also walked 5,000 steps, excuse me. Our day four, they also walked 5,000 steps. And then our day five, they also walked 5,000 steps. So this will then look something like this, meaning they walked the same number of steps in each day for 5 days. When talking about gradient, excuse me, so with gradient here, we'll be looking at whether there is a rate of change that is taking place here. We're going to look at whether the slope is steep, or if there is even a slope for that matter, because that's what's going to tell us whether there is a change or not. But we saw that looking at the actual numbers, there is no change. But mathematically, let's then look at what that means. Remember that our gradient is going to be our change in y over our change in x, right? So in this instance, it will be our change in steps, and then this we will divide it by our change in days, right? So our change in steps in this context will then be 5,000 minus 5,000, right? And you divide this. So we can take this day here and we can take that day there. So this was when this person traveled 5,000 on the 5th day, minus when they traveled 5,000 on the first day. So this will be 5 minus 1. So you can see this becomes 0 over 4, which then becomes 0. Why does this then become 0? That's one thing we need to think about. It tells us that there was definitely no growth, right? There was no change in the number of steps that this person walked in each day for 5 days for the first week. And what that would then mean is our rate of change is supposed to then be 0. Now let's look at if we're to write this as a model, which would then be an equation, how would then this look like? So with our equation, it means that the equation will then be steps is equals to just 5,000, right? What does that mean? It means in each day, you are just walking 5,000 steps. No change whatsoever. So this is one example of when there is really no growth that is taking place here, or when there is no change that is taking place. Now, let's look at if they just spice things up a bit. They take a weekend off, which is our day 6 and 7, and then they start with day 8. Day 8, they say they now need to walk 5,000. Remember, the goal is to get to 10,000 steps a day for health purposes. On the 9th day, they walk 5.1. Was there a change there? Think about that. On the 10th day, they walk 5.2 steps. Was there a change from the 9th day to the 10th day? Think about that as well. And then on the 11th day, they walk 5.3 steps, so 5,300. You look at, is there a change between day 10 and day 11? And then lastly, on day 12, they walk 5,400. You also think about, is there a change there? So you can see that there was a change of plus 100 steps. There was a change of plus 100 steps. There was a change of plus 100 steps. There was another change here of plus 100 steps. Now, excuse me. Now remember, with this, we are busy talking about a simple pattern. A simple pattern means that there is a constant change of whatsoever that is happening. In this context, there is a constant change of the number of steps that the person is adding in each day as they are progressing with their health journey or with their walking, right? And specifically, that will be 100. So what does this then mean? What you need to think about right now before we go to the next thing would be, what would then be the rate of change? Or how would we find our rate of change? How will the equation, the model that we need to use to predict what will happen in future, what will then it look like as well? So that's what you need to please be thinking about. Now you can see here that the person started on day 8 with 5,000 steps, and then on day 9 they went to 5.1. On day 10 they went to 5.2. On day 11 they went to 5.3, and then on day 12 they went to 5.4, right? And if I was to draw a graph, this is how the graph will look like. So already you can see that I have a gradient here, right? So this will have a gradient, which will mean the steepness of this thing is exists here. Now let's look at if I wanted to calculate my gradient. So my gradient will be change in steps, right? And you divide this by change in days. Now you will see that change in steps, let's look at 5,400 minus the initial, which was the 5,000, and we will divide this by, they walked 5,400 steps on day 12, so that's 12, minus they walked 5,000 steps on day 8. which means that's 8. And therefore, this will be equals to, if you subtract there, it will be 400 over 4, which will then be 100, right? So as we saw that with the previous table that we were using to explore this data, there was a plus 100 that I was adding in each day. So that's what the gradient tells us. What was the rate of change? How was it changing due to the number of days that we were looking at? Now let's try and develop a model that we will use, which in this instance will be an equation that we will use to try and talk about this. If I want to find the equation here, I will then say my equation is going to be the steps will be equals to my gradient, which is then the 100, multiplied by d. The d represents number of days, then plus the initial number of days that, the initial number of steps that the person walked. So maybe let's look at day 8, right? So in day, so if you look at maybe day 8 here, you will then say that this is going to be 100 times that plus that. So you would be looking at what exactly does it mean to try and find the number of steps that the person will walk in each day that we are trying to talk about. So that's the big idea here. So the big idea here, one is there is definitely a change. Is the change constant? Okay, true, it is constant. Number 3, can we develop a model to predict what will happen maybe, let's say, in day 20 if this person continues to walk the very same thing that they are doing? True, yes, it will be there. And then lastly, what will then be the rate of change in terms of the number of days that they're doing this? And if I was to predict here, then it would mean you will then know to say, in a certain number of days that the person has walked, this would be the number of steps that they would have walked in that duration altogether. So that's the big idea here that we are trying to talk about. And then also it will be how many days did they walk, and then you try and use that to talk about how many steps did they actually walk for all those days or for a specific day in particular. But going back to the previous one, you can see that with the previous one that I looked at here, all right, so let's just quickly do this. With the previous one that we looked at, we saw that there was definitely no growth that was happening here, right? So if we were to predict on this, to say if this person, they want us to know on day 10 how many steps the person will walk, if this was the graph that we are dealing with, then we will definitely say that they will walk 5,000 steps because there is no change that is taking place. And the number of steps is a constant value as you are progressing through, because remember our gradient was 0 there. And then on day 20, how many steps will they walk? Think about that. On day 50, how many steps will they walk? If this is the nature of our graph, and this is the nature of information that we know. But if we go to this one here, you can see that there is a gradual increase which was plus 100 each and every day. So you can then tell us that if I want to find what the number of steps is, maybe on day 15, I can use the model that we'll develop here to try and talk about that. And then that will give us the two relationships that we're looking at. So this is a perfect example of what growth means. Remember, we're still looking at the big idea, which is growth, right? So this person, will this person reach then their target that the doctor has recommended for them? True, they will in this second scenario. But in the first scenario where they just said, okay, I'm just gonna walk 5,000 steps in each and every day, they will not get to 10,000 steps a day. And that would have been maybe the recommendation from the doctor. But with this second scenario, they can then get to that. So this will be a perfect example of what we are talking about when we're saying there is growth. The first one will be a perfect example of a very opposite thing to what it means to have growth in this particular example. So that's what we are actually trying to look at with the big idea. Remember, just to summarize what we've looked at so far, our big idea is growth. Under growth, we're looking at a pattern. Under a pattern, we're looking at a simple pattern. Simple pattern, what does it mean? It means our growth is constant that we are measuring. The rate of change is a constant rate of change as we are progressing with our growth. And then we can then develop a model that will help us to predict in the future what will happen if we wanted to know. And that's it from me for now. We're going to go to a quick ad break and we'll be back just now. Stay tuned.